Hi friends, welcome to this channel. Here we are going to look at this problem, clone graph. This video will follow the previous two videos on clone something, right? So here let me first explain what we want to do. First, the data structure involved will be dictionary or hash map. And the thing or the algorithm we want to code is homomorphism. So in other words, we do the same thing in parallel universes. So here there are two spaces involved. One is the key space, and the other is the value space, right? Because this is a graph problem, it involves traversal. For traversal, there are two coding formats. One is iterative format, the other is recursion, right? Or recursive format. So in this video, I'm going to use iterative format. So this is to digest details. So with that said, let's look at the coding. So first, we know that from the problem statement, you see the number nodes in the graph is in the range given by the closed interval 0 and 100. It can be null, right? If it were null, so we're going to, if not node, so we're going to return null, or just return. So this is one edge case. So now let's look at the generic case. First, I want to, because we have done this if check, now the node is not null. I want to map it to a value space. So I'm going to use a D. So D node, so D is a dictionary, right? So D node will be new node. So notice the signature, right? We have a value, we have neighbors. So this neighbor is either an empty list or a list of node objects, right? So here the value would be node value. So with that done, now we can do traversals. So here let me use a stack. So it means that I'm going to use depth first traversal. So basically, well, stack. Then we can first get a node. The node, let me use V to represent the node. A stack pop, right? And then because we have already mapped the node, the root start, so we only need to check the neighbor and the relation of neighbors with this guy. So for neighbor in node, that's the V, right? Neighbors. So this is the, I guess, the field name. Let me copy that in order to avoid mistakes. So we have this one, right? So now, if neighbor not in D, it means not visited yet, right? So then what we do, we first map it to the value space with a new node instance or node object. That will be node. The value will be the neighbor value, right? And because it's not visited yet, so we're going to append this to the stack. So this neighbor. And each time we made this map, right, and then append the neighbor into the stack top, then what we want to do is to do this thing. Do the same thing in the parallel universe. So what we do is this, D. So we want to find the neighbor, right, the V. So it's the neighbors in the mapped in the value space will be append the corresponding nodes mapped to the value space. That will be D of neighbor, right? So it's for each neighbor you're going to add this to this list. So with that done, so we just need to return D node. This is the full coding for this problem. So before we make further comments, let me first do a test. Stack. So let me use S. Run it. It passes the 3 test cases. Now let's look at the generic case. Yeah, it passes all the cases. This is the one way. So here, as I mentioned, you can also write it using recursion. This is also very neat. So this is a good exercise, right? With recursion. Actually, if you write with recursion, the code can be very short, right? So with that said, I guess that's it for the current problem. You're welcome to check out other videos in the clone something playlist. And also you are welcome to check out some other problems in other playlists in our channel. And hopefully these playlists or summarized problems will help you practice. Thank you.